Lake Natron looks like Mars flooded with Pepto-Bismol, a wide, glassy basin reflecting the sky in impossible pinks, ringed with mineral towers that jut from the horizon like fossilized teeth. From above, it's hypnotic. From the ground, it's unsettling. Up close, the shoreline is a gallery of stone, birds and bats, their feathers frozen into crystalline shells. This death is chemical, not natural. The water here is so alkaline, its pH registers around 10.5, almost as caustic as oven cleaner. No waves, no bird calls, just wind and the silence where life should be. And yet one creature thrives. Millions of flamingos feed on an algae so toxic that nothing else alive dares touch it. Before we dive deeper, quick poll. Which animal do you think could survive a lake this deadly? A. Bird B. Insect C. Fish D. Bacteria. Vote now in the comments. This isn't just a place of death. It's a perfect chemical experiment. And the results are about to get strange. The secret behind Lake Natron's deadly beauty lies not in poison, but in chemistry. The lake sits above a volcanic rift, an underground crack where Earth's crust is literally tearing apart. Heat from below forces ancient minerals up through the bedrock, flooding the shallows with sodium carbonate, the same compound the Egyptians once used to mummify their dead. When the lake evaporates, the caustic powder left behind begins to harden. Over centuries, these minerals precipitate into towering columns called tufa towers, alien spires that rise from pink water like crystallized ghosts. They aren't just rock, they're solidified chemistry, proof the water is always trying to turn the world to stone. Each drop of natron's water strips moisture, burns skin, and seals life in glass. Feathers fuse, scales glaze, eyes crystallize. The high alkalinity creates a perfect barrier. No bacteria, no decay. Decades later, the bodies remain pristine. In a sense, the lake doesn't just kill, it stops time. But it can't stop evolution. And here's where the dead zone becomes a nursery. Reveal flamingo colony, waiting in shallow pink water. They nest on islands of poison. This lake mummifies trespassers but protects believers, a natural cathedral of chemistry. Lake Natron's curse begins in fire, but so does its miracle. The lake sits above a volcanic hotspot in the Great Rift Valley, where magma continuously pushes carbonates and minerals upward through fractures in the bedrock. When rainwater dissolves these minerals, it becomes hyperalkaline, the opposite of acid, but equally corrosive. The pH spike should sterilize everything. Instead, it created a new form of life. In the lake's shallows, microscopic algae called spirulina evolved to survive the caustic chemistry. They still photosynthesize, but their pigments tolerate, and even harness, the extreme alkalinity. Those pigments bleed red, dyeing the water a color that looks like blood seen through glass. To most life, that crimson glow is a warning. To flamingos, it's a signal. They fly hundreds of kilometers to reach this toxic cradle, feeding on the spirulina that no other creature can stomach. The shallow, sun-baked water stays warm enough to incubate their eggs, while the same caustic salts that could dissolve flesh form a moat no predator dares cross. Even as temperatures reach 60 degrees Celsius and the air itself seems to burn, the colony thrives on the edge of impossibility. If you think that's the most mind-bending survival story on Earth, hit the like button now. What looks like a lake of death is, in truth, a womb forged from fire. But there's evidence the lake is still changing, and this time, the change isn't geological, it's industrial. On the southern shore of Lake Natron, industry eyes a controversial prize: soda ash, the same compound that gives the lake its deadly chemistry. Plans for extraction have been proposed, blocked, and proposed again, each time threatening to disrupt the fragile balance that sustains life here. The irony burns. To extract this mineral, companies would need to pump the lake's brine, draining the shallow waters that incubate flamingo eggs and feed microscopic algae. These hyperalkaline pools, once crimson with spirulina, now risk fading to gray as the algae die, leaving skeletal feathers drifting into the water. This is a lake of paradox. While soda ash fuels batteries that power cleaner energy across the world, its removal could poison the cleanest creation on Earth. Life here thrives at extremes, on the edge of chemistry and climate. But human intervention could unravel what took millennia to forge. If the water dries, flamingos won't vanish entirely. They would scatter to other alkaline lakes like Bogoria or the Makadikati pans. But with 75% of their global population breeding at Natron, their numbers would collapse. Not extinction, but decimation. A dream not erased, but shattered into fragments too small to sustain. Yet perhaps the pattern is not unique. Our relationship with extreme beauty often follows a cycle. Awe, possession, loss. Lake Natron is not the first wonder to face human greed, and it will not be the last. Lake Natron isn't dying because it's fragile. It's dying because we've learned to see beauty as resource, wonder as commodity. The same alkaline chemistry that turns flesh to stone has become, in our economy, worth more extracted than preserved. But here's what the flamingos understand that we don't. Extremes aren't obstacles. They're sanctuaries. The deadliest water on Earth is also the safest. Poison becomes protection. Humans haven't evolved for this perspective. We see a caustic lake and think, hazard. We see pink water and think, postcard. We see soda ash and think, profit. We don't think, leave it alone. Maybe we can't save every extreme place. Maybe the cycle of awe, possession, and loss is written into human nature as deeply as the minerals are written into Natron's water. But knowing the pattern exists, seeing it clearly, might be the first step toward breaking it. Or maybe the lake doesn't need saving. Maybe it's trying to teach us something. The most precious things in existence are the ones we cannot own, the ones that turn us to stone if we try to grasp them. What does our desire to possess beauty tell us about ourselves? What wonder near you is threatened by progress? Tell us in the comments. We began at a lake that turns life to stone, and we end here, asking a different question. What turns us to stone? Maybe it's not the chemistry. Maybe it's the pattern itself. The way we see beauty and immediately reach for it. The way wonder becomes resource, sanctuaries become mines, and living things become specimens. The flamingos don't see a deadly lake. They see home. They've evolved not to conquer the poison, but to become part of it. To see threat as shelter. To see scarcity as abundance. We haven't evolved that perspective, but we can learn it. Not every wonder can be saved. Not every miracle will survive us. But the ones that do are the ones we witness without grasping, love without owning, let exist beyond our need to control. Lake Natron doesn't need us to save it. It needs us to understand what we become when we try.